So in this tutorial, we're going to work on interpreting elevation and working on gradients, and this is a follow-up to Lab 1. So let's take a look at our topographic map of Math State Park. And we know that the contour interval is 20 feet. So what that means is between any of the small brown lines, or the brown lines in general, it's 20 feet difference. So we're starting at 700, which is a thicker line. And then as we go down towards the creek, we should go down each line by 20 feet. So 680, 660, 640, 620, 600. Makes sense, I hope. You should see that underneath the picnic area, that line curves around and then is below or above that road, and it's still 600 there. So our 600 foot contour line. Okay, so now we have an idea of what the contour lines are around in that region, so we can estimate halfway in between 680 and 660, point 1 is going to be at 670 feet. All right, let's take a look at another area that was challenging for a lot of people, and it's that little contour line sort of above that green line, the green line of A, and this would actually be where it intersects the river, 580. So notice this is one contour down from 600, so it would be 580. Now let's try to do 4. It's halfway in between. Our best estimate would be around 590 feet. Okay, let's zoom out now, and we're going to set up a situation where we can measure gradient. So we're going to start with a point that's right by 3 there, and our line is going to end with a point that's at the 600 foot contour near the river. So this will be the line that we're figuring out the gradient for, or the path we're figuring out the gradient for. Okay, now let's be thinking about how we're going to estimate the elevation at point 3. Hopefully you've got some ideas, and we've got that 859 at the top of that hill to help us. Okay, the nearest label contour line is actually 700, and then the next 100 up every 5 line. So the bolded or the index contour should be 800. We know that the contour interval is 20 feet, so the next line should be 820, and then 840. So point 3 is basically in between 820 and 840. So we don't know exactly what it is, but you might make a guess that it's just about 830, and so that's the guess we're going to use. And then we've got our lower elevation point, the other end of the line, at 600. All right, so let's review a little bit what we're talking about when we mean gradient as I adjust the image to give us a little more room to write. So let's remember about the definition of gradient. It's usually defined as the rise over the run. And if we can recall, the rise is basically the change in elevation between 2 points or along a line. So let's try to do rise first. So we've got the highest point subtracted from the lowest point. That would be the change in elevation. So it's 830 minus 600 gives us 230 feet. Now let's talk about the run. So the run is going to be the distance across the ground, basically. And so we actually need to use the scale to do this. So I'm kind of scooting the map around to try to see what's going on here. All right, so we've got a bar scale where there's a line, and it indicates that that's 1 mile. So the easiest way to do this is actually get out a scrap sheet of paper and mark off the length of the actual line that we're trying to find the gradient for, and then line it up basically with the key or the scale. And ideally, you're not doing this on the computer, fighting with it, trying to get it to move over. You've actually got a piece of scrap paper and you're counting it out. And I did this on both. And for this line, what I ended up getting then was that the run is equal to about 4 miles. Okay, so we've got a rise over run for our gradient. Our rise is 230 feet. Our run is 4 miles. So there's 2 ways we could do this. We can simply do the math and simplify our fraction and leave the units as 5 feet per mile. The other thing we could do is set it up so that we're actually getting rid of our separate units. so we have the same units throughout. And to do that, we have to basically introduce a term that is equal to 1. That is, 1 mile is equal to 5,280 feet. And set it up so that we're canceling out the units. And so this is going to give us, basically, it's usually something really that looks really small and indicates that there's no units.